So today, I would love to talk this little thing about app-specific sequencing. Some of you guys might have heard about it here and there on Twitter. Some people like to call it ASS, and I sometimes go with that, right? I go with whatever people say, right? So that's that. But yeah, so that's what I'm going to be talking more about today. Just a quick agenda, 3 main problems. What is app-specific sequencing? I might just call it AS from here on out. Hopefully you don't mind. And then AS for intent, right? What does that mean for intent? And then why AS and not L1s and L2s? And hopefully any of the L1s and L2s here, don't get mad at me, please. So yeah, no bad intention there, right? Just to try to show what AS means, right? All right, cool. So what is AS? I think before we kind of get into this question, I kind of wanted to walk through a little bit of ideas behind why this means, why this matters for applications that is building in this space. As many of you guys might know, there's been a lot of fat protocol thesis that has been swirling around in the space since 2019 or 2021. I forgot when the article came out, but the space has been changing. And I kind of categorize it in a bit more granular sense so that people can see it better, what exactly those that the value accrual means from the protocol perspective. So you have things like ordering, sequencing, data like DA, execution, meaning actually performing the state transitions. And then you have the network effect, which I guess you can call it the voodoo of the Ethereum, right? And then on the other hand, you have the application who control the front end, which also has branding itself, like Uniswap front end. And then you may have fees on the swaps or whatever the activities that entails, right? So bridging may have some fee as well. And then in the next variation, you have the less fat protocol, right? So you have Max Riznick that has been pushing for a lot of the PFOF type of things. So now MetaMask can be making millions of dollars a year, right? And then that's kind of slowly taking away those value accrual to the application and front end levels. And the fat app thesis that I kind of like to call it is this, which is where the application itself take control over the sequencing of their own transaction and their own order flow, right? So that's kind of how you sort of see the ordering sequencing responsibilities sort of gradually transition upwards to the applications. And at a high level, I think that's also kind of the idea that is underpinning the app-specific sequencing as well. So in a sense, right, what we are doing here with AS is to try to make dapps great, right? People complain about oh, dapps doesn't accrue value. No, maybe it can, right? Maybe, who knows? And that's why I want to talk about AS. So today, the transaction supply chain roughly looks like this. I'm sure you guys are all pretty familiar with this, but just for those who might not be familiar, you have order flow that is coming in, transaction that is coming in from public mempool and private mempool, going to builders, going through relays, the auctioneer, and then go to the proposers, right? And then the block will be created. With app-specific sequencing, what it may look like is taking our answer network as an example, which is also a decentralized sequencing network that we have. We'll have app-specific mempool for, in our case, for our DEX, app-specific mempool. The network will perform the bundling of those transactions, the sequencing of those transactions, come up with a big fat bundle, which I just call the answering bundle. And then this gets submitted together with the public mempool and private mempool into the builders, which then gets processed later on by relay and the proposers. So there are 3 key properties that I want to emphasize here with AS. One is the restricted sequencing rights. So AS application typically achieves the effect of sort of app specific by having this own delegated sequencer sets. With this delegated means that you can have whatever sort of like consensus mechanism you want around it, but you have some sort of like rule enforcing that what kind of sequencer can join, and that those sequencer would then perform specific sequencing for your application. So that's why the app-specific aspect comes into, right? So you have a restricted sequencing rights. And then another benefit of that is by having restricted sequencing rights, now you also have control on how your states gets updated by what sequencers. So now you have more granular control over like the state update as well. Like state mean like contract state, yeah. And then obviously that comes naturally with app-specific mempool, which can be just a bunch of like messages, signed orders that is kind of propagated within the whatever AS infrastructure that you're running on. And then lastly, and probably the most important part here is the order agnostic outcomes. And what that means is that basically the ordering of those transactions within this bundle that is created from this app-specific sequencing is not impacted by the external underlying transaction supply chain. So if you look at this, the bundles that comes out of the app-specific sequencing does not get somehow like reorged or whatever like within the bundle by the builders or by the proposers. So the execution outcome of this specific bundle is agnostic to the ordering by the block builders, or if it is a vanilla builder, the proposers. So that's what I mean by order agnostic outcomes. So in a sense, we, with AS, is trying to bring back sovereignty to dapps. Like I know sovereignty is a big word, so I would certainly want to dive into it a bit more. But when I say sovereignty, well, I said like dapps gain sovereignty over sequencing and thus execution. When I say sovereignty, it means that dapps can control their state updates, and basically like the execution of any of those like transactions going through the contracts by controlling the sequencing. So that's what I mean by like gaining the sovereignty over their own applications, and which previously was all controlled by block builders and those people like trading shops, right? And then so as I mentioned, like the dapps would gain sovereignty over their own states by those gated state update by sequencers. And then one more very important part, which kind of leads into the intent aspect later on, is that the sequencing and execution in this AS framework can be hyper optimized for the users. And when I say hyper optimized, or when I say like optimize, what are we optimizing, right? The optimization that we're talking about is the economic payoffs. This is a concept that was mentioned quite extensively by Tarun on his paper towards the theory of MEV, the second version, where he laid out a lot of the math, which I'm not going to dive into it here, but it's a very interesting paper. I would highly recommend you guys to take a look at it, where he talked about how the app-specific sequencing kind of optimized the user economic payoffs that is related to that application. So the optimization here is for the economic payoff, right? Any confusion about this term about economic payoff? Like people good with it? Any confusion? Well, I can ask later, obviously. So yeah. So how does AS facilitate in-protocol intent? Just to kind of be on the same page about it, I just quoted a tweet. Sorry, not a tweet, like a definition of intents that I found, on some random Google search, and then it turns out this guy called Georgios and this guy called Quintus talked about it already. So yeah, that's the definition, right? I'm not going to regurgitate it, but the idea is that you have this point A and point B that you know of, and then you're basically computing something off chain to potentially figure out how to. Basically, you're trying to like a path seek between A and B, and then that's kind of how you essentially execute on the given intents. Oh yeah, sorry, I forgot the meme, but this meme was just to kind of showcase, like, some people consider the intents are just some sort of limit orders. Maybe other people not so much, and just there are various speculation. Anyway, so I believe that as is a new user-centric design space for applications to hyper-optimize users' economic payoffs. The sequencing rules that sequencers have to abide by is, again, very user-centric in a sense that it's optimized for the user's execution outcome, which oftentimes can also be an intent. So if we take, for example, CalSwap as an example, you are giving a price that hopefully would be the best price possible at the time of your execution of your trades. That is your intent, and CalSwap is trying to fill that intent the best way possible, in a sense, right? And that is how CalSwap provides users the best execution outcome, best economic payoff. And in a similar sense, anytime you're interacting with, let's say, bridging with a cross, for example, you are trying to maximize your economic payoff via doing these actions. And in a sense, what we are trying to do with AS is to maximize the economic payoff within our protocol by having this customized sequencing rule that can optimize for the users. Hence why I call it user-centric. And then another aspect, off-chain compute. Because of the complexity of all of this compute, maybe some node-to-node, peer-to-peer type of communication, a lot of this moved off-chain as well. And then the last key part was that all orders, signed messages, are intents of some shape or form, right? So fundamentally, what we're dealing with as, we're not receiving transactions, right? We're not receiving any transaction. We're receiving signed messages that is expressing what they want to do. And then we, as an application, are exactly fulfilling or attempting to fulfill the best to our best capacity, achieve the results that they want from the messages we receive. So yeah, that's kind of like the link in between intent and as. So yeah, I think as has always been built for intent. That was our intent. That was our intention. Yes. But this comes the next question: why as and not other L1 or L2s, right? Why? I've prepared a table that hopefully maybe is a bit too small, so like for those who got no wearing glass, maybe a bit hard to see, but I will just kind of briefly go over. I kind of compare as L1, L2 in this framework. So on this side, you have L1, L2, based L2, and sovereign application. Sovereign application meaning like apps that are running with AS on whichever native execution layer, whether it be L1 or L2, doesn't matter. Starting from execution overhead, AS application does not execute because there's just an dapps that is running with its own sequencing rule. So there's no execution overhead. There's no ZKP. There's no fraud proof or any sorts. So we don't deal with any of that. Liveness overhead. When it comes to liveness overhead, the smart contract can decide what part of their storage slots or what part of their states can be updated via the sequencers. Meaning that some parts of it can be dependent on sequencers, some parts of it not so much. And that's kind of up to the smart contract developers to kind of designate what parts should rely on sequencer, what parts shouldn't rely on sequencers. Which then comes to asset control. Asset control meaning that does the smart contract actually lock the assets? Does the smart contract, if something happens, that would somehow make the assets not withdrawable, right? And you may have seen in some scenario that when the L2 sequencer goes down, it becomes incredibly difficult for the assets to be withdrawn from the bridging contract. In some cases, as far as I'm aware, there are like maybe only like couple, maybe 2 or 3 chains L2s that actually have an escape hatch and forced inclusion mechanism, which in itself is also a pretty high barrier of entry activity for any normal people to really use as well. Not to mention there's a significant delay period as well. And with asset sequencing specifically, the asset control is, again, can be a lot more flexibly designated in a sense that smart contract can decide if this asset has to be locked and dependent on the sequencers. If, for example, the LP tokens in this contract does not have to depend on the sequencers updates of any sorts, if the sequencers goes down, the smart contract can still allow anyone to withdraw the assets whenever they want. So there's a increased degree of flexibility around what part is dependent, what part is not, and you have still maintain asset access based on the design of the protocol. And then obviously the last part is that we're just an application. We're not an L2, we're not L1. We're just building on some ecosystem, maybe L1, like Ethereum, maybe Ethereum L2, whatever. People remain access to the native liquidity and order flow. So yeah, I think I kind of went over this throughout, but that's basically the idea. So yeah, if you're thinking about building something in the intent space, and accrual values that to the application also like have user treat well, like remember there's always an ass that is sitting around that you can leverage. Yeah, thank you very much. Thank you.